Hey guys, it's been a while since I've uploaded, and I'm sorry for not uploading, but I just wanted to make this video to update, or to give you guys some updates on what I've been doing. So, last time I showed off this my programming language, it was pretty well. It was it was a while ago, so I don't even remember what I showed off. But anyway, if I compile here, and then I run, you'll see we've got privilege levels. I'm gonna let's see, use standard IO. Now this is just the normal, like the echo and all that stuff. So we can do echo 1, and then let me make sure my voice is okay. So I've added a garbage collector and immutable strings and tables, just like Lua. So if we do table A and then table.c equals 1, echo a.c, that's 1. But we can also, just like in Lua, we can also do a.b equals a, and then we can do circular tables. So we can do a.b.b.b.b. .c, and then it'll be 1. There's also, like I said, there's also immutable strings. You can do strings, and these will be garbage collected. Once they're no longer needed, they'll be destroyed. And they also, just like in Lua, they're only, if there's a string that's exactly the same as another one, then it will only use the memory for one string. It will like basically share the same memory address for both strings if they're the same. Let's see, what else is there? I also added this thing called Bytecode version 2. So the old Bytecode version 1 was whenever I was just learning how to make a language, and I kind of did it really badly. So operator precedence was sorted at runtime. So like, let's do a time test. So let me get this little function here, and then I'm gonna go and I'm gonna do master script, so that there's like no initialization or anything. If we run this, it's oh wow, that's actually pretty fast. But anyway, that's it. That's bytecode version 1. Let's look at bytecode version 2. So if I uncomment this, if I uncomment bytecode version 2, and then I compile again. Also, I tried to do libffi, but I gave up on it. I don't want third-party libraries. So anyway, if we do that same time test, look at that. It's like twice as fast, and it's also more compact. It also is more. It's simpler, and it's so simple, in fact, that with the power of this compiler called OpenWetCom, I was able to actually port this language to DOS. Look at this. I'm in DOSBox, and I can do standard IO echo 1. Look at that. And then we can do function x int 16 b return b stop, and echo x 8 plus x 4. And it crashed. God damn. Ah shit, I'm gonna have to fix that. Anyway, let me see. Oh, you know what? Hold on. Let me compile this again. Look at this. Look at it go. And that's all the files. If I do DOSBox, I want to show you how fast it is. Standard IO, and then uint16c equals 0 while 1 echo c++. Look at how slow it is. Oh my god. It's very slow, but that's because it's 16-bit, and I'm also using far pointers. So yeah, but if I hit F1, it'll stop. I'm wonder why it didn't. Hold on a second. Let me try that again. And I might have changed something somewhere. Turn beast. Echo x4 plus x4. Fire. Oh my god. Alright. Oh shit. I'm gonna have to fix that shit. It was working earlier. That's really stupid and annoying. I don't like that. Look at that. It's only 400. It's only 500 kilobytes. I'm gonna try to make it even smaller too. If you go here, okay. Calls. Execute. I'm gonna see if I can figure out what I changed. I already. Oh damn it! I restarted. God damn it. Shit. You know what? Sometimes whenever I enable bytecode, or whenever I enable the bytecode printing, it miraculously fixes it, just because it changes the way the structure of the binary is. If I load this, let me try it again. X int 16b return b stop, and there's the bytecodes. Use standard IO echo x4 x4. Nope, it doesn't work. Ah, shit. You know what? I'm gonna go fix it, and I'll be right back. Alright, I fixed it. So I just had to remove this queue operation call right here, because that's like from it's from the bytecode version 1 logic. I forgot to remove it, but anyway, now we can do this and use standard IO, and then I can echo x8 plus x4, and it's 12. Look at that. So let me break down the bytecode real quick. So right here we've got call opcode or bytecode, call bytecode. So basically there's this call right here, and then it immediately goes over to this call right here, and then this is the if I'm correct, this is the signed integer bytecode. If I look, those are the types. 22 signed integer opcode. Yeah, look at that. And then number, and then 2, that's how many bytes wide the number is. Then we've got little endian order, so then we've got 8 with the least significant byte first, and then 0. So there's the 8, and then after that it also pushes a symbol, which is the X, so it pushes this, and it says 0 here, but it actually represents 1, just so that symbols can be either one character long or 256 characters long. So 0 is actually 1, and 2 is actually 3, and 4 is actually 5, basically, and so on. But anyway, we got the ASCII code for X right here, and then the end call bytecode, which ends this, and then there's another call right here, another call the 39 is the other call, which is the other X, and then we have the assigned integer, width, number again, and then the same thing, it's the symbol, and that's X again, and then there's the end call, and then right here, this is 62, that's plus, that's the add up bytecode. If I go over here, 26, that's the add bytecode. And then we've got, and then after it adds those two, it pushes the echo symbol, which is 4, which is actually 5, because then we got the underscore, the E, the C, the H, and then the O, and then the end call, and then end statement. That means it's the end of this line basically, and then this is the end script. The number 33 is the end script opcode. That means that it basically whenever it hits that, it sets the script state to complete. And you can also do if statements. So if you do if 1, or actually let's do if 0, echo 1, else if 1, echo 2, stop. And look at that, there's that 2 right there. And I guess that's it for now, I guess. Maybe not. Let me see if I can find anything else to show off. Oh yeah, also, you can actually execute machine code. So if I do exec, let me turn off this, hold on, first let me turn off this, where is this? I need to turn off this bytecodes. Where the fuck is that? Byte developer byte display. Oh yeah, also another thing I might mention is that this is this whole, like, all the source code is all written in ASCII, and it's also 100% C89 ANSI standard compatible. And that's how I was able to port it to DOS. I basically to spend a few days rewriting it in C89 syntax. And what the one weird thing about C89 is that you have to declare all the variables first. But anyway, let me compile again. Oh yeah, actually, let me close DOS for a second, and let me compile optimize. This is using GCC's optimizer. But anyway, let me show you how fast it can go. And how fast it can count. And if okay, use standard IO events C equals 0 while 1 echo C++. Look at that. Pretty much 1 million a second. That's ridiculous for an interpreted language. At least for what I've wrote. I mean, I'm sure that professionals or whatever can do better or some shit. I don't fucking know. But anyway, yeah. Oh, also, I'll leave this running for a little bit just to show you something cool. While that's doing that, I will. Let's see if I can find something. Yeah, actually, you know what? Fuck it. I'll just unpause whenever it's done. Look at that. It just disabled the script from timeout. There's a scheduler. There's a built-in scheduler in this language. This language is basically just a big integrated scheduler. So you can actually use the scheduler. Let me see. You can actually use the scheduler. Like, for example, let me see. Let's say we can want to print 1 and then wait 2 seconds and then echo 2. Look at that. It just waited. And while this is waiting, other scripts can be executing too, because there's a scheduler that the scheduler will be executing 1 bytecode at a time per script in like a loop. But anyway, let's see. Well, that's it for now. I hope you guys think this is cool. if you're looking forward to seeing this actually be like go into beta and like actually me release it, just let me know in the comments. I'm gonna make it open source, don't worry. But yeah, I hope you guys enjoyed, and just leave a like or some shit, I don't know. But yeah, bye.